Welcome to Math on Ice, December 2012, Integral Equations. In this paper, there is one question from part B and two questions from part C. So, we will see three questions. First question, for the homogeneous Fredholm integral equation, phi of x is equal to lambda times of integral 0 to 1 e to the power x plus t phi of t dt. A non-trivial solution exists when lambda has the value. We need to find the value of lambda. It's a direct question. So it is phi of x is equal to lambda times of integral 0 to 1 e to the power x e to the power t into phi of t dt. Take out e power x, phi of x is equal to lambda e power x integral 0 to 1 e to the power t phi of t dt. Take this part to be c. So consider c is equal to integral 0 to 1 e to the power t phi of t dt. So we will have phi of x is equal to lambda e power x into c. So put c is equal to 0 to 1 e to the power t phi of t dt. Instead of phi of t, you just substitute this equation. We will have lambda e to the power t into c, because phi of x is equal to lambda e to the power x into c means phi of t would be lambda e to the power t into c. It's a function of t, right? So this into dt. We can take out lambda and c. So lambda and c taken outside, which is 0 to 1 integral, and inside the integral we have e to the power 2t into dt. Now this is c is equal to lambda c integral 0 to 1 e power 2t into dt. C cancels, we get 1 is equal to lambda. Taking integration of e power 2t, we get e power 2t divided by 2. Applying the limits, we get lambda by 2 into e power 2 minus e power 0, which is equal to 1. So we get 1 is equal to lambda by 2 into e power 2 minus 1. We need to find lambda, right? So lambda will be 2 divided by e squared minus 1 is equal to lambda. Lambda is equal to 2 divided by e power 2 minus 1. 2 divided by e power 2 minus 1. Fourth option is the correct answer. Next question. The initial value problem d squared over by dx squared plus y is equal to 0 with the initial conditions y of 0 is equal to 1 and y dash of 0 is equal to 0. First, we will verify whether this condition is satisfied by all the options or not. So here y of 0 is equal to 1. Since because we have 0 here, so we will put the upper limit as 0. If lower limit and upper limit are same in an integral, then the integral will become 0. So here this part will become 0 and here also 0, 0, 0. So every option is going to give you y of 0 is equal to 1. This is being satisfied by all the options. Next, we need to verify y dash of 0 is equal to 0 for all the options, and for that we need to take the derivative by using the Leibnitz rule. We will go by option. For the first option A, we have y of x is equal to 1 plus integral 0 to x t minus x into y of t dt. So y dash of x is equal to integral 0 to x, taking the derivative of this part will be taking the derivative of t will give you 0, and taking the derivative, this is actually dou by dou x of t minus x into y of t dt, and your upper integral limit is you have x here, so d by dx of x, and here substituting x instead of t, we get x minus x into y of x, and the lower limit is 0, so we get it as minus 0. So this will give you integral 0 to x. Taking the derivative, we get minus 1 into y of t dt, and here x minus x will give you 0. So we get y dash of x is equal to minus integral 0 to x y of t dt. And y dash of 0 is equal to 1. Y dash of 0 is equal to 0 here, because this is y dash of 0. When you apply y dash of 0, your upper limit will also become 0. So we get this right hand side to be 0. So this second boundary condition, initial condition is also satisfied. Now we need to verify y double dash of x. Y double dash of x is equal to, take again the derivative, we get minus integral, this full part is going to be 0 because there is no x part here, minus integral 0 to x d by dx of, we get y of t into dt, so this is going to be 0 anyways, and then applying the upper integral, we get the negative is outside, so we get plus, the upper part will be y of x, and minus the lower will be equal to 0. So we get y double dash of x is equal to minus y of x. So we get y double dash of x plus y of x is equal to 0. Now we need to verify whether it is the given. Yes, it is the given question. So it is the given initial value problem. Y double dash plus y is equal to 0. So option A satisfies. So option A is correct. Now we will check for second option. Y of x is equal to 1 plus integral 0 to x t plus x into y of x dx. So we have second option. Y of x is equal to 1 plus integral 0 to x plus t into y of t dt. T plus x into y of t dt. So this is equal to y dash of x is equal to integral 0 to x y of t dt plus when you apply the upper limit we have x plus x, we have 2x into y of x, and then when you apply 0, y dash of 0 is equal to this first will be integral 0 to 0 will become 0 and the second part will be x is here. So when you apply 0 it will become 0. So this is satisfying the initial condition also. So we'll take the second derivative. Y double dash of x is equal to this integral part will become 0 and you will have only the upper integral side. So we will find the thing which is equal to y of x. And then plus taking the derivative of this side will give you 2 times of x into y dash of x plus y of x. So when you solve, it is y double dash of x is equal to y of x plus 2x y dash of x plus y of x. This is not equal to the given initial value problem. This is different and this is different. This one is different. So the second option is false. This is false. In third one, y of x is equal to 1 plus integral 0 to x xt y of t dt. Y of x is equal to 1 plus integral 0 to x xt into y of t dt. So y dash of x is equal to integral 0 to x. We get t here, t into y of t dt, and then applying the upper limit we have plus t into y of t dt. By the Leibnitz rule we will have x into y of x, and when you apply the lower it will become 0. So this is equal to integral y dash of x is equal to integral 0 to x t into y of t dt plus x squared into y of x. When you check the initial condition y dash of 0, that is giving you 0 here and also 0, so it is satisfying the condition. Now we will verify y double dash of x, which is equal to, when you apply the double dash, here it will become 0 because it is term independent of x. So this integral part will vanish and we will find the upper term only. Upper term will be x into y of x, and then the lower term will become 0 because it is a constant here in the lower limit, and then taking derivative for this part we get x squared into y dash of x plus y of x into 2x, but this right hand side is not present here. We need to have minus y, right? So this implies y double dash is equal to minus y, but we are not getting the same thing. So third option is also wrong. This is also wrong. And the fourth option, y of x is equal to 1 plus integral 0 to x minus t into y of t dt. Fourth one, y of x is equal to 1 plus integral 0 to x minus t into y of t dt. X minus t into y of t dt. Here we have y dash of x is equal to integral 0 to x. When you take the derivative of this x minus t, we have simply y of t dt, because derivative of x will give you 1 and derivative of t will vanish. So we get 1 into y of t dt, that is y of t dt, plus the upper part will give you x minus x into y of x, and then the lower will give you minus 0. And this y dash of x is equal to integral 0 to x y of t dt, and it satisfies the initial condition y dash of 0 is equal to 0. Taking the second derivative you get integral the y double dash of x is equal to, this integral will become 0, and when you apply the upper part it will be plus y of x. So that is giving you y double dash of x minus y of x is equal to 0, but in the given question it is plus y of x. Y double dash d squared y by dx squared plus y is equal to 0, but we are getting here it as a minus y of x. So the fourth option is also false. Now I will give you the Leibniz formula, the general formula, integral psi of x to phi of x, f of x comma t into dt. When you take the derivative of this, d by dx of this full thing would be, this is equal to integral psi of x to phi of x, dou by dou x of f of x comma t into dt, plus d by dx of the upper integral, derivative of the upper integral, multiplied with f of, instead of this t, substitute phi of x, and then minus d by dx of your lower limit into, instead of t, substitute psi of x. So this is the formula. Next question in part C. The integral equation phi of x is equal minus lambda. Okay, we will rearrange and write the problem. Phi of x is equal to f of x plus lambda times of minus 1 to 1 cos of pi of x minus t into phi of t dt. Now we need to verify the nature of the solution. Okay, so this problem is based upon the matrix method, finding the matrix, and we have to evaluate based upon the linear algebra concept. Now we need to find Ax is equal to B. We need to find the matrix A, we need to find the matrix B, and we have to evaluate the rank of the matrix A and then the augmented matrix rank and everything we have to determine, and we will finally determine the nature of the roots. Okay, now here kernel k of x comma t is equal to cos pi of x minus t, which is equal to cos pi x cos pi t plus sin pi x sin pi t. So this will be alpha 1, beta 1, alpha 2, beta 2. Ax is equal to B is the matrix, right? So the matrix A will be equal to 1 minus lambda A11 minus lambda A12 minus lambda A21 1 minus lambda A22. Since we have alpha 1, alpha 2, beta 1, beta 2, we will find a 2 by 2 matrix. And then the X matrix will be C1, C2, and the matrix B will be equal to V1, V2, where Aij is equal to integral A to B beta I of x into alpha j of x into dx, and Vj is equal to integral A to B f of x into beta j of x into dx. Now we will find one by one. A11, which is equal to integral minus 1 to 1. This limit is from the question. So we use the same limit. So minus 1 to 1. Here beta 1 is cos pi x and cos pi x alpha 1, and we get cos squared pi x into dx. As we know that cos squared x 2 cos squared x is equal to 1 plus cos 2x. This formula we will take, and this is equal to, this equals to integral minus 1 to 1 plus cos 1 plus cos 2 into pi x divided by 2 into dx, and this is equal to 1 by 2. When you integrate 1, you get x, lower limit is minus 1, upper limit is 1, plus when you integrate this part, it will be 1 divided by 4 pi sine 2 pi x minus 1 to 1. So this is equal to 1 by 2 into 1 plus 1, and this part will give you 0. So it is equal to 1. So we get A11 is equal to, so that implies A11 is equal to 1. And A12 is equal to minus 1 to 1, beta 1 and alpha 2. Beta 1 is cos pi x, alpha 2 is sin pi x. So we get cos pi x and sin pi x into dx. As we know that integral minus a to a cos mx cos nx dx is equal to 0 if m is equal to n. This is going to be 0. As we know that integral minus a to a cos mx sin nx dx is equal to 0 if m is equal to n. So we get this part to be 0. So this is equal to 0, and similarly A21, which is minus 1 to 1, beta 2 and alpha 1, sin pi x cos pi x. So we get the same thing, sin pi x cos pi x dx, which is equal to 0 again, and a22 which is equal to minus 1 to 1, sin pi x cos pi x, beta to alpha 2. So we get sin squared pi x into dx. As we know by the formula, sin squared pi x, 2 sin squared pi x is equal to 1 minus cos 2x. We get it as which is equal to integral minus 1 to 1 minus cos 2 pi x divided by 2 into dx, which is equal to 1 by 2 into 1, this is x minus 1 to 1, and then minus 1 by 4 pi sine 2 pi x. Applying the lower and the upper limit, we get this second term fully 0, and this part would be equal to 1. So we get the matrix A matrix is equal to 1 minus lambda, because A 1 is 1, and then 0 here, and here also 1 minus lambda. We need to find the matrix B. B is equal to V1, V2, right? So V1 will be equal to integral minus 1 to 1 f of x into beta 1. Beta 1 is cos pi x. So we get cos pi x dx, and then beta 2 is equal to sin pi x. So we get V2 is equal to minus 1 to 1 f of x into sin pi x dx. Now f of x is an unknown function. We cannot integrate without knowing the function. We will see the options one by one. A unique solution for lambda not equal to 1 when f of x is equal to x. So f of x is equal to x and lambda is not equal to 1. Okay. When lambda is not equal to 1, it should have the determinant of a to be not equal to 0. So lambda, when is we will just verify when the determinant of a is getting 0. So here the determinant of a is equal to 1 minus lambda the whole square. When it is 0, we get lambda is equal to 1. So for lambda not equal to 1, we get a determinant of a not equal to 0. For lambda is equal to 1, we get determinant of a is equal to 0. Okay, so the first thing they have given a unique solution for lambda not equal to 1. Here determinant of a is not equal to 0 in this case. And if determinant of a is not equal to 0 and f of x, your function f of x, determinant of a not equal to 0 and f of x is not equal to 0 means that implies the integral equation has a unique solution. So we get unique solution. F of x is not equal to 0, so we get a unique solution. No solution for lambda not equal to 1 when f of x is equal to 1. No solution for lambda not equal to 1. Now, no solution means the determinant of a should be equal to 0. Here determinant of a is not equal to 0 for lambda not equal to 1. So no solution is not at all possible. Option B is false. And the third option, no solution for lambda is equal to 1 when f of x is equal to x. Yes, this is a possibility. No solution for lambda is equal to 1 means we must arrive determinant of a should be equal to 0 for lambda is equal to 1. Yes, for lambda is equal to 1, we are getting the determinant of a is equal to 0. Now we need to verify for f of x is equal to x, it is satisfying or not. We will take f of x is equal to x here and we will find v1 and v2 and we will find the augmented matrix and then we will just find the solution. So v1 is equal to integral minus 1 to 1. What is our f of x here? X is given, cos pi x into dx. So by integrating by uv rule, we get v1 is equal to, you take u is equal to x and integral minus 1 to 1 cos pi x dx is equal to integral dv, and don't apply the limit here. So we get uv minus integral u dv is equal to uv minus integral v du. So we get x into, here v will be sin pi x by pi is equal to v. So we get sin pi x divided by pi. Applying the lower and the upper limit, minus integral v is sin pi x by pi, lower and the upper limit, into dx, because du is equal to dx. So when you apply the upper limit here, sin pi will become 0, and when you apply the lower limit, sin of minus pi will also become 0. So this part will become 0. And this function sin pi x, sin x is an odd function. When your limit is from minus a to a, integral minus a to a f of x dx is equal to 0 if f is odd. F of x is odd function, then it will become 0. So this is going to be 0. So we get V1 is equal to 0. And V2 is equal to integral minus 1 to 1 f of x into sine pi x dx, right? So integral minus 1 to 1 f of x is x given, sine pi x into dx. The same thing here, u is equal to x, integral sine pi x dx is equal to integral dv, v is equal to minus cos pi x divided by pi, and du is equal to dx here. So this will be equal to minus 1. Okay, we need to apply the uv rule. We will have u is x and v is minus cos pi x by pi. Lower limit is minus 1, upper limit is 1, minus integral, already a negative, so this negative will make it positive, cos pi x divided by pi into du is dx, lower limit and the upper limit. So this is equal to, when you apply the upper limit, we get minus, this part will become 1, cos pi divided by pi. And when you apply the lower limit, already a negative, here also a negative, so we get a positive, already a negative, or else I'll write like this. Take negative completely outside, x cos minus 1 by pi outside, x cos pi x minus 1 to 1, this is plus 1 by pi. When you integrate this part, it will be sine pi x divided by pi minus 1 to 1. So this is equal to minus 1 by pi. This will give you 1 into cos pi minus 1 into cos of minus pi. And when you apply here, sine pi is 0, sine of minus pi is 0, so this is going to be 0. And then minus 1 by pi, cos pi is minus 1, so we get minus 1. And then this minus into minus will give you plus. And then here, cos of minus pi. Cos of minus pi is again cos pi, we get it as minus 1. So this is equal to minus 1 by pi minus 2, so we get 2 by pi. V2 is equal to 2 by pi. We got V1 0 and V2 is equal to 2 by pi. B is equal to 0, 2 by pi. And A is equal to, we get it as 1 minus lambda. Here lambda is actually equal to 1. So when I put the terms here in the matrices, we get A matrix to be 0, 0, 0, 0, and then B matrix is equal to 0, 2 by pi. When I write the augmented matrix, rank of A is equal to 0 and A by B is equal to 0, 0, 0, 0, and here 0, 2 by pi. Rank of A by B is equal to 1 and it is not equal to rank of A. Therefore, no solution. So this option is true. Infinite number of solutions for lambda is equal to 1 when f of x is equal to 1. So possibility is there because we get determinant of A is equal to 0 when lambda is equal to 1. When lambda is equal to 1, we get determinant of A to be 0. So it has a possibility of getting infinite number of solutions. Now we need to verify for f of x is equal to 1. So for that we need to separately find V1 and V2 as like the previous option. So we will find V1 is equal to integral minus 1 to 1. We have f of x which is equal to 1. So replacing f of x by 1, we have cos pi x dx and here sin pi x dx for V2. So we have cos pi x dx which is equal to, when you take the integration, we will find this as sin pi x by pi, upper and the lower. When you apply both, you will find it as 0. And then for V2, which is equal to minus 1 to 1 sin pi x dx, and this is an odd function and this is going to be 0. So we get A matrix is equal to 0, 0, 0, 0 after applying lambda is equal to 1 here, and then we will find the rank of the augmented matrix A by B. So that will also be 0, 0, 0, 0 and then 0, 0. So we get rank of A by B is equal to 0, which is equal to rank of A. So it has an infinite number of solutions. So infinite solutions. So this option is also true. That's it. Thank you.